I think if you look at the trajectory that AI has taken and has driven computing down, the explosion in compute requirements that we've seen, both in terms of number of operations, also in terms of the amount of data, has just been incredible. If you look at some of the biggest challenges that we have in the world today, and I think computing, especially driven by AI, is a clear example.
Understanding the need for the market and providing the supply for it.
Who are the partners? Who are the players that are delivering those to the market? And that's a complex constellation of software developers, operating system developers, processor developers, OEMs who build the devices.
Welcome, Naveen, to the AIM Media House podcast, Simulated Reality. How are you doing today?
I'm doing very well. Thank you very much for having me.
Fantastic. We are going to talk about the AI accelerator hardware market. And I think it's a very interesting space to be in. Obviously, there are the bigger giants who are working to like NVIDIA, AMD, Intel to reduce the time for processing in AI and building models for AI engineers and data scientists. One of the things that I've seen is that a lot of startups that are coming in the market as well. So it'll be interesting to learn from you as to how they're competing against these big giants and what kind of separates them, right? But just to start, let's start with learning about your journey. How did you embark on it? Your research background and what led to kind of you thinking about this product and building it from scratch. I saw that there was a lot of collaborative process that went into it. Your students helped, and so let's hear the story of how it came to be, and then maybe we can dive into it.
Sure, I'm happy to do that. It's an exciting story, at least for me personally. And I've been a professor at Princeton University since 2009. And my research here has focused on really next generation approaches to computing. So we, noticed very early on that computing is, of course, extremely important. We also noticed very early on that things you can do with computing are becoming more and more powerful. But in order to do those things, what we've seen is that the performance, the power, the fundamental resources that we need to be able to do that compute is increasing very, very rapidly. And in fact, as AI started to come into the picture, it started to increase even more rapidly. In fact, not only did the compute requirements start to increase more rapidly, but the compute capabilities started to increase more rapidly. So it's a very exciting time. It's a very, very exciting time to be a researcher in this space. But I think in particular, it's a very exciting time to be somebody who's doing fundamental research in this space. I think if you look at the trajectory that AI has taken and has driven computing down, the explosion in compute requirements that we've seen, both in terms of number of operations, also in terms of the amount of data, has just been incredible. And so even in the best of days of computing and computing hardware, where Moore's law was in full flight and so on and so forth, and transistors were scaling, the pace at which compute requirements have come on has far exceeded anything that we could have done there. And so it became a really clear picture, if you're in the fundamental research space, that look, we need to do things differently, very fundamentally differently. And that's where kind of the fun starts, right? That's where now you say, okay, listen, the way we've done things in the past isn't going to work. Let's start to really think, sort of broadly and disruptively about what can be done. Now, my own group has been very interested in next generation, new paradigms for computing. But I think what's important to remember about computing is that they're systems, complex systems. They're full stacks, right? They start from the physics of devices that do little manipulations and so on. They go up to circuits and architectures that allow us to sort of have those devices work together towards larger and larger functions and capabilities. But then there's the whole complexity of the software stack. And I would say one of the unique aspects of my research group at Princeton is we're an extremely full stack group. So we build chips, we tape out chips, send them to foundries to get fabricated. We even fabricate transistors and chips in my lab. But the point is we build very complex chips. So chips that can really be representative of the challenges that we face in industry and state-of-the-art systems. And then we also build that full architecture and software stack. So we build the software to talk to those chips. We build the software that figures out how you take applications and map them to the chips, and then we build it all the way up to the programming interfaces where people are developing those applications. That's a highly collaborative process. But by having all of that within one research group allows us to really now think on a fundamental level how to take computing in these new directions.
Yeah, I think this journey is really cool, right? And I'm seeing more and more of these research people who have been in research or academia, suddenly kind of think of an idea, they think that they can monetize, and they start their own company, and full blown, it's a process. Then firstly, how do you kind of manage between these two jobs? You're a full-time professor at Princeton, you have to kind of go to classes, at the same time score students, and then at the same time run your business, do the research, because it's a continuous process. I'm sure that every year you need to evolve. I would just like to learn how you balance all of this, and how do you kind of manage time between scaling that business. You've always also raised money, so I'm sure there is an entire effort that went behind going in front of the VCs and presenting, and it's an interesting journey. Like, how do you kind of...
The most sort of top line answer to that is you need to have a lot of support around you from the team that you work with on the university side, the team that you work with on the startup side, but also from the institutions, right? You need to have a university that understands the value of innovation and driving research out of the research lab, and you need to have a startup and investors and stakeholders who understand the importance of fundamental research and the impact that can have in innovation. So there needs to be an alignment across all of these things that I rely heavily on and that I work closely with. And I think the alignment comes from the following aspect, Kashyap. If you look at some of the biggest challenges that we have in the world today, and I think computing, especially driven by AI, is a clear example of such a challenge. These are big problems. They're not going to be solved in a sustainable way without really transformative solutions. And the reality is we need those solutions in society, but those solutions in many cases are going to be sourced out of fundamental research. That's how we think about fundamentally new ways that can put us on new trajectories to meet these requirements that would otherwise be unsustainable. And so if you think about that, universities have a very important role to play in solving major societal problems. I think the example of EnCharge and the research that we did at the university and are now commercializing is a clear example of this, right? This is a fundamentally new way of doing compute. In order to really understand it, in order to really solve all of the issues around it, and in order to put it into a platform that people can use, there's a lot of fundamental research that has to be done. I can't go, and we didn't go, and just raise money when we had the first idea of how to do this new and transformative approach to computing, because there's a lot of fundamental challenges that need to be solved all the way up the stack. If you do go and raise that money, unfortunately, often you don't give these new fundamental innovations the chance to really solve real problems, because when you start focusing on commercialization directly, now you lose the opportunity to really research things and understand them deeply. Having done that in the university, solved the problems, made mistakes, landed on the right solutions, de-risked this completely new technology. Now, when you have the opportunity to go and commercialize, you can start to be extremely product focused, not worry about technology, start to think about the customers, the solutions, the ecosystem partners. And so there's a real, sort of continuity in delivering impact that starts with fundamental research and fundamental technological transformations, all the way through to innovation, commercialization, building products, putting them into real customer solutions, and so on. So there's a real, sort of consistency and synergy across these. And I think everyone understands.
A lot of things coming together, essentially. Like, I think that's a phenomenal story. I always because wondered as to what that... I'm sure that the support system is there, but I'm sure you have to be very driven, right, Naveen? As a person, you will have to be very driven to be focused on so many ideas, because a full-time job in Princeton, it's in itself is so much by itself, right? But it's phenomenal that if things have worked out. With hard work comes luck. So as well, everything is put together. You've been able to put out a product, you have been able to raise the money. Now let's talk about the technology itself, right? And I want to see how you're competing with the bigger giants, and why would someone want a chip built by EnCharge AI in their computers rather than something built by NVIDIA or AMD, and its humongous set of different libraries and different offerings. So if we can talk a little bit about that technology itself.
Yeah, and I think broadly, if you look at the landscape here, Keshav, you mentioned at the beginning, there's a lot of AI startups. There's also a lot of activity in building new AI hardware at the big companies, at the incumbents. But really, if you look at the landscape, there's two categories of efforts here. There's people who are building, sort of digital accelerators, really purpose-built for AI compute. So what they're doing is they're taking the same fundamental technology we've had for years, right? Digital circuits and architectures, and saying, well, let's really specialize these as much as we can to solve the problem of AI. And that's really what NVIDIA is doing and Qualcomm is doing. But you're limited in how far that can get you in terms of sort of its ability to meet compute power requirements and compute performance requirements. You're using the same fundamental technology we've always used, and you will do as well as those technologies can do. Now, there's also startups that are trying this, but it's still the same fundamental technology. And so we're all trying to engineer within the same constraints of physics. Now, there's this new category where there's new paradigms to computing, and that's where my research has focused over the last 15, 20 years. And the interesting thing here is now you're saying, okay, let's break the barriers of that physics. Let's harness new physics to build new approaches to computing that can give us much higher efficiency, much higher capability. The challenge there is there's also startups that are looking at that, a whole range of them, but these are, sort of fundamentally different approaches. There's so many technological barriers that we need to understand and solve for. And that's the distinction with EnCharge. We've come from a really differentiated fundamental technology, but we've spent the time to really understand it, to de-risk it, develop it, so that we're in a position to be very product and customer focused. So that's a little bit sort of philosophical. Now there's also what the fundamental technology is and what new physics does it access and what barriers does it break. And I'm happy to talk about that also. But I think on a high level, that's the positioning that we have in this landscape.
Yeah, so I think one of the things, yesterday I was just reading somewhere, someone who said that, business is mainly innovation and marketing, right? So innovation is something that you have gotten covered, right? But at the same time, especially when it comes to academics running businesses, a business acumen is something which is completely of a different ball game altogether. Are you collaborating with someone to expand this business? How are you getting that message out? Clearly, your product is something different than what usual companies are building. There's a research. I'm sure there's a patent as well for it. And, so what does it take to kind of scale the business side of things when you build such a product? How were you able to raise money? Because that's entirely another ball game. Last week I caught up with another Silicon Valley entrepreneur who raised money, and I was just trying to understand how did he walk through this journey to kind of raise that funding. But as an academic, how did it work for you? What did you put in your presentation that convinced the VCs of the value for it? And now how are you going to use that money to scale?
Yeah, look, I think at the end of the day, in order to be successful as a business, you have to solve a problem, and it has to be a problem that really matters and that people really care about, preferably a lot of people, so that on a business level, you're having a sustainable model for building revenue and so on. Of course, it has to be a big enough problem also so that you're having impact on the levels that you want to have from your fundamental research. So, I think the journey here is really about coming from a fundamental technology, but really understanding what problem it solves, and then working with partners who are seeing the problems that we described in AI computing to then figure out which is the right problem among these to solve and how should we solve them, right? Because listen, our solution rather, is this fundamental solution, but it needs to be positioned in a way that it actually solves the problem that somebody is facing. And as the more specific we can get about that problem by working with a specific partner and by working with a specific ecosystem, sort of that partner and you together are going to impact, the better you will solve that problem. And so, really it's about articulating what that problem is and making sure that it's a big enough problem that people care about. If you look at the space of computing today, there's a lot of problems. And I would say the paramount one is, compute power consumption is very unsustainable, especially as we start to, sort of scale out AI, right? Today, it's done largely in the data center. The data center in many ways is restrictive, right? It limits cost. It's limited by cost structures. It's limited by the ways that data and software services are managed in the data center. It's limited by latencies and privacy concerns and sort of deploying that data in the data centers. So there's a clear trend actually we're seeing both in terms of accessibility to AI and in terms of user experience and user meaning from AI, where AI is being disaggregated into all sorts of devices, our laptops, mobile devices, all of these kinds of things. And now you start to think about, well, what do those systems look like, and who are the partners, who are the players that are delivering those to the market? And that's a complex constellation of software developers, operating system developers, processor developers, OEMs who build the devices. And so it's really critical to articulate what problem we solve and work together with them to make sure that we build a product that fits into a solution that significantly impacts the limitations that that category of computing device faces.
Yeah. And so what you explained to me is essentially understanding the need for the market and, providing the supply for it, right? It's much more complex when there is that level of innovation involved in it. And I'm sure as academics, you have all the brain power to kind of build this innovation. My question is more from the perspective of the marketing side of it, because there are many products, right, who are actually good, but they never could scale from a business perspective. I know the product is unique. The product is something which a lot of companies are demanding for. Reducing AI compute time is one of the most important struggles. It's one of the highest costs that these companies are bearing, right? Apart from cloud and human resources. So that problem is solved. The problem, it provides a good solution for the problem. But when it comes to the business side of things, right? Enabling marketing solutions that reach out, creating a brand recall value. Have you hired someone separately for the business side of things? How are you looking at it? How are you utilizing that money that you have raised to generate business for you? So
to be clear, right, I am one element in the EnCharge operation. And my role is very limited when you think about all of the things that EnCharge needs to do. We have a very robust team that's doing the production development. That's a team of engineers. But as you pointed out, we also have a critical team that's doing product strategy, product marketing. And I think, like I said, you need to start with a fundamental problem, and then you need to figure out whose problem it solves, and hopefully that's a big enough, important enough base of people whose problem it solves, right? Articulating all of that is critical through the product strategy and positioning. We have a team in the company now over 50 people, and a large number of them are very focused on working with customers and partners to make sure that they understand the role that this plays, so that we can demonstrate the impact of our technology. And then from there, of course, we move to a phase where we want to develop broad awareness and so on, so that there's that brand recall value also. But this is not an operation. I'm a small piece of this operation.
I think you're being too humble. But, overall, with the market, AI accelerator hardware market, I think there are quite a bit of startups that are coming up, right? It's not only EnCharge AI. There is a lot. There are 2-3 more startups that have raised money as well along with it. So you are not just competing with the big giants, you're also competing to kind of capture the market, which is working at that. Does your research, your patent stand out from what the other companies have done? If yes, how? And if it is similar, then how do you plan to compete with the market? And if it is not similar, how do you plan to get that message out that it is something, you're doing something better than your competitors?
Yeah, so definitely the place that all of this starts from is that we have a fundamentally differentiated technology. And that technology is something called analog in memory computing. If you look at AI today, and you framed very nicely how big a problem AI is in terms of power, in terms of performance, in terms of being able to run models, increasingly complex models. If you look at AI models today, I think I pointed out previously, they've gone in two directions. They've exploded in the number of operations that we need to do, and they've exploded in the amount of data that they do these operations on. So we need to solve both of those problems simultaneously. In-memory computing is one of the very rare architectures that can solve both of those problems. It keeps the data in memory to solve the data movement problem, and it uses analog techniques as opposed to standard digital techniques to do the compute in ways that are very, very efficient and very, very high density, so we can fit compute inside the memory. Now, this is very differentiated. So there's a lot of people working on all sorts of different digital technologies. And like I said, those are the technologies that have always been around. We're limited by the physics of what that can do. Analog in-memory computing, we've known actually for decades that analog can be 100x more efficient and 100x more dense. The problem is analog can be noisy. And so the big problem that EnCharge solved and our fundamental technology solved is it's given us approach to do very precise, very scalable analog compute to start to gain this order of magnitude, these order of magnitudes kind of advantages. So we're doing something very fundamentally different. And what's important here is somebody needs to care about the advantage that this gives you. And then we need to put this into an entire product where they can actually use and benefit from that advantage. So we spend a lot of time having those conversations with the partners who are really driving the forefront of AI, right? The ones who really need that high efficiency, that high performance, who are truly trying to deliver that user experience really at the forefront, working with them to understand, well, what are the needs? What are the needs today? What are the future needs? How do we build a platform that is programmable so that AI and AI developers can continue to innovate? That's been the critical lifeline for AI, right, in the last 10 years is the pace of innovation, so that we can keep up with that pace of innovation and this hardware platform can go where the developers and the markets need it to go. So that's really key for us, is having those conversations and making sure folks understand that, and we understand from them how to deliver the right product.
Yeah, I think the messaging will be key here to kind of understand. So you're saying that other competitors like Accelera, Gigaspace, all of these, they are not working in this analog in-memory computing. They're working in a hybrid of analog and digital, and you are working specifically only with analog. And the problem that you were able to solve is the inconsistency of the output of it because of the noise that it can create. Is that my correct understanding around it?
Absolutely. So all of the players that are out there, most of them, and including the ones that you mentioned, are all digital solutions. They all are limited by the fundamental physics of what you can do with digital technology, right? And whether you sort of frame it as digital in memory, digital accelerator, GPU, whatever it is, it's all the same fundamental physics, and the gains are all, the efficiencies are all at the same point, more or less. Analog computing is a very fundamentally new and transformative approach. I shouldn't say it's new. Actually, we've known about it for many, many years, but it's a fundamentally different kind of physics that gives us this new, sort of efficiency and performance point. But making it scalable, making it robust, making it so that you could build a software stack so that your hardware is programmable, scalable, can go where the markets need it to go. That's the critical piece that the company has solved.
Fantastic. I think my last question to you would be, so what next, right? So what lies for EnCharge AI in the next 1 year, 5 year, 10 years? What's your vision? Where do you see yourself as a company, not just from the perspective of scaling, but also that scaling the business, but also the technology? I'm sure that your research team will keep working on it, keep improving the technology as and when we speak. So that's very fundamental to why EnCharge AI is established as a company and scaling business. So what's next for you?
Yeah, let me do the following, Kishyap. I'll start broad, and then I'll start to hone in on the more what's next near term. I think broadly speaking, we feel very privileged to have a fundamental technology, but also a team that can deliver that technology that's, like I said, fundamental. So it can address a very broad range of AI applications. Now, we intend over time to do that as much and as widely as possible. I think that's what's required to make AI fully maximally accessible, available in all of the cases and to all of the people who need it. But I think what we want to do here is this gets done in steps. So I think what we want to do is look at where are the biggest opportunities, where our technology can most immediately have the maximum advantage, and start with those. And then go from having built that out as a product to now augmenting that product with additional auxiliary capabilities and features and partnerships so that you can then address the next biggest opportunity and progress in that way. And so if we think about the first big opportunity that we see for EnCharge, that's what we're very focused on in the near term. In the next 6 months, in the next 12 months, our product roadmap is really about delivering solutions where AI can scale out of the data center into platforms, client devices, mobile devices, edge platforms, so that, first of all, by the sheer number of these devices, now you have a scalability for AI to achieve. Secondly, because of the proximity of these devices to humans and the various tasks that we do, the user experiences and the capabilities, the ways in which we can benefit and leverage AI expand and open up. And so these are the immediate focuses for us. And so if you start to think about these devices, mobile devices and client devices, there's very well-established ecosystems. We've been relying on these devices for so many years. There's a cohort of people who are delivering those. The idea now is to take EnCharge's offerings and advantages and introduce them into these devices so that now the impact of those devices can grow through AI. And so the aim for us is to work closely with those ecosystem partners to deliver AI very broadly to this large market category where you have major efficiency, power efficiency, performance, cost challenges, which we think that our fundamentally better solution can address.
Thank you so much, Naveen, for coming for this interview. It was very enlightening to understand the AI accelerator hardware market. As researchers into the AI space, this is something very fascinating for us. As I mentioned, it's a big problem statement, one of the highest cost components to some of the biggest companies. So I'm sure that your solution will scale and, it will see solutions across different companies, and all the very best. Thank you so much.
Thank you so much. It's an exciting space. Thanks for your interest in it and for the time.